Okay, I'm going to explain the solution to your quiz yesterday, but what I need you to do right now for those who receive their papers back is to number that page 78, and we will file this in your binder so you will have something to look at for your final exam. Alright, the first question, we are looking for the energy, capital E. So on your given, you have power in kilowatts and time in minutes. Before you plug in the numbers, remember to change kilowatt into watt and minutes into second. So here's the conversion factor. You simply multiply 130 by 1,000 to change it back into watts, and multiply 5 by 60 to change it into seconds. Plug in those numbers in the equation, so we're multiplying them. Your final answer should be 3, 9, and 6 zeros. Now, this is a scientific notation to shorten the way we write numbers. So you move the point all the way after the first number and count how many times you moved it. In this case, it's 7 times. So your unit is watt seconds. Okay? Remember, time is always in seconds and power is in watts unless I ask it to change into horsepower. Number 2. For question number 2, this is similar to your power lab. So the process is the same. You start from the mass, changing the mass into force. In cases like this, where you have mass and you're given the time and the height, you need to use this equation. Notice that F cosine theta times D is your work and divided by time. So we can't solve work unless we have the force. Changing mass to force, we simply multiply it by 9.8. This is the answer. Now you plug it in the equation, times cosine 0 times 2 meters will give you 20, will give you a certain number, okay? Your number now will be multiplied by 25 since he did this 25 times. We're looking for the total work. So your answer times 25 will give you 24,500. Then now you divide it by 60 to get your power in watts. Number 3 is very similar to number 2. The only difference is we're changing the watts into HP and our height is not in meters yet. So 16 centimeter, if you are reading the problem correctly, is the height of each step or probably each stairs. There's 50, so you will multiply your height in meters by 50. So here we go. Changing centimeters to meter, divide the number by 100 or move the decimal point twice to the left. It becomes 0.16 times 50 stairs. The total height is 8 meters. So we will use that to solve for our work later. But now we start from the mass, which is 40 kilograms. And what's the first step? Change the mass into force by multiplying it with the G 9.8. So you will get 392. Plug that over here on your F cosine 0 times 8 meters will give us this much of joules. And again, changing that to power, we divide it by the time, 40 seconds. The watts is 78.4. When you change the watts into HP, here's your factor. For 1 horsepower, it's 746 watts. So you divide the watts by 746 and you will have 0.11 horsepower. Number 4. Number 4 is an example where we are using the equation P equals force times velocity, since we are only given the mass and the speed. Notice that the mass is in grams, and like we said, mass should always be in kilograms. We divide the number by 1,000 or move the point 3 times to the left. That's what it is. And we will multiply the mass by the G to solve for force, which is this much. Now you plug in your force times your speed, you will get 7.84 watts. Number 5. For number 5, I saw several methods that you did here yesterday, and I didn't bother to stop you because I want you to kind of analyze it yourself. But this is the correct method here. Okay, you first solve for the work for both Will and Ben. Work is force times cosine theta times the distance. Notice that I just put F times D, since cosine theta here is also 0, which is equal to 1, and the distance is not given. In that case, we will assume that they are lifting it both at the same height. So if I'm assuming a distance of 1 meter, and I have a force for Ben, which is 100 newtons, times cosine theta 0, it will still be 100. And if I multiply that by 1 meter, I will still get 100 joules. Okay? Question is, how many times did he do the lifting? It says 10 times. So you will have to multiply that 100 joules by 10. His total work is 1,000 joules. If you look at Ben's work, he lifted it up 100 newtons too, 10 times also, the same height. So you will still end up with 100 amount of work done, but he also lifted it up 10 times, so 100 times 10 will still give you 1,000 joules. So in fact, they both have the same amount of work, the same newtons, the same distance, and the same cosine theta. The difference will be in their power. Notice that Will did it for 1 minute, which is 60 seconds. So we divide 1,000 by 60. Use your calculator. His power is 16.7 watts, while Ben did this only for 10 seconds. So 1,000 divided by 10 will give us 100 watts. Notice that Ben is more powerful than Will because Ben did it in a shorter amount of time compared to Will with the same amount of work. Number 6. Number 6 is a conversion. It's simply asking you to change kilowatt hour into watt second. So take note of this process because you will be using this in the next problem at the back. 1 kilowatt hour, change kilowatt first to watts, so we multiply it by 1,000, and change hour into seconds. There are 3,600 seconds in an hour. So you simply multiply 1 times 1,000 times 3,600. You will get 3, 6, and 5 zeros in your calculator. This is a scientific notation, so if you move the point to the front between 3 and 6, you did that 6 times, so that will be your answer. Alright, at the back, same process again, but for number 7, some stuff to remember. The mass of each passenger is 54.9 and there's 20 of them. So before you use 9.8 to change that to force, remember to multiply 54.9 by 20. That will give us the total mass of the 20 passengers. Now to get the force of that, we will multiply that number by 9.8, and this is the amount of force. Plug in the force on your equation here, times cosine 0 times the height of the elevator, and you will come up with this amount of work. So to get the power, divide that work by 60 seconds, and you will have 932.6. Changing that to horsepower, divide it by 746. Your answer is 1.3. For number 8, there's a lot of given in number 8. But notice that we have energy here in kilowatt hour and the time is in minutes. So we can actually use the equation energy divided by time. Some of you yesterday, I just let you divide 5 by 60. That's okay because that was the equation. But for the sake of properly canceling our units, this is the correct process. We wanted our kilowatt hour to be in watt second. So if we divide it by the seconds in time, we will come up with a watt unit. So the changing 5 kilowatt hour into watt second, you will follow your conversion process that I just showed you in question number 6. That means that the given kilowatt hour will be multiplied by 1,000 and 3,600. So we have 5 kilowatt hour times 1,000 times 3,600 will give us this much amount of watts second. That number will be divided by 60, not 1 minute, because we want it in seconds, and you will come up with this answer. Okay, it will be 3 and was that 4 zeros or 5 zeros, and then you move your point, and this is in scientific notation. Okay, number 9 is quite easy. This is just plugging in the force, which is 340. Cosine given the angle is 50 degrees. The height or the distance is 500 centimeters. So we change the centimeters first to meter. What do? We divide it by 100, or moving the point twice to the left. That's equal to 5 meters. So times 5, total answer divided by 30 seconds. It's 36.4 watts, but we needed this in HP. So you divide it by 746, and we come up with 0.05.